Okay, we're in section 29 of the notes now. So again, really at this point, you really should be catching on to what we're doing. What are we doing? I'm just kind of going over each section in a standardized way. What I mean by that, I encourage students to read the contents if they have access to it. I encourage students to look at the examples and try to understand those. And then it's time to exercise, all right? So part of it's just understanding what's presented. I'm not fully, but enough to start moving forward. The document that's being prepared over here is for the Prison Mathematics Project participants only. It will be published at a later date, though. All right, my name is Ron Bannon. This is a draft version of Webster Wells' Advanced Course in Algebra. That dates back to 1904. All right, if you do need to reach out to me, my email address is Bannon, that's B as in boy, ANNON.US. All right? Okay, this appears to be a pretty short section. What I mean by that, I'm looking at the contents, and the contents start on page 448, and then the examples start on page 449, right? So let's take a look. If you look at this over here, they talk about, problems involving fractional equations leading to linear equations with one unknown number, all right? It appears to be word problems, all right? So I'm looking at that. What I want to do is, that's the way Wells treats it. We're going to go over here, and we're going to look at the way I'm going to be treating it. Now, when I'm reading this problem over here, number 1, it says A can do a piece of work in 8 days. Now, I want to point out this is a work problem, and work, I'll write this down for you. Work, that's something that you're going to accomplish, is equal to the rate you work, right? You do something per time times the amount of time you work, all right? So let's take a look, and let's write this down. So I'm going to say we're talking about A. So I'm going to put down work. A's work. And let's write this down. And what's that going to be? WA, RA, I'm just summarizing, and TA. And I will read. And then, there's B in the problem too. I'm reading that as well. And I'll put down B's work. And that's going to be W sub B, R sub B, and T sub B. Okay, let's read it. It says A can do a piece of work in 8 days. What does that mean? Whatever the work is, his rate is going to be one job every 8 days. All right, now keep in mind we're talking about one job every 8 days. Then it says B can do the job, right? One job in 10 days. So B is clearly slower. Then the question is, how many days can it be done if both work together? Well, I'm going to say in reason, I hope you realize it's got to be less than 8 days. And why is that? If A was working alone, he'd do it in 8 days. But if B helps out, it's going to be substantially lower than 8 days, all right? Because B does help out, all right? Now, the question is how many days? I don't know. I'll just say X is the number of days it takes. So let's write this down. Again, I'm looking at the formula. What's it going to be? Well, it's going to be rate times time. And so this would be X divided by 8. And this would be X divided by 10. Now, what do they do? Well, they add their works together to get one job done. So I'll write that down. So what I'm going to write over here, X over 8 plus X over 10, and they complete one job. So I'm adding their works together to get one job done. What am I going to do now? Multiply both sides by the LCD. What's the LCD? It's 40. All right, let me write that down for you. LCD is 40. You multiply both sides by 40. What do you get? 5x plus 4x. And then 40 times 1 is 40. What do you get over here? Well, you get 9x equals 40. Divide both sides by 9. You get 40. Divide by 9. Someone says, I don't know what that means anymore. I hope you, when you read it, you read it again. It has to do with the time it takes them to accomplish this task. So 40 over 9. I don't think it's a good idea to say 40 over 9 now. And I'll tell you why. Most people would have no understanding what you just said over there. So 40 over 9 hours. That doesn't make it any better, by the way. What I'm going to do is write as a mixed number. And this may not make it much better for you either. But 40, I'm sorry, I said hours, I meant days. They clearly said days. Sorry about that. I'm always thinking work is in hours, but in this case it's days. Again, I want to point out what I mean by that. They tell me it's in days. Everything is days in the problem. My time unit is days. Sorry about that. Whoops. So I'll write this over here. What's it going to be? Well, 9 does go into 40. And how many times? It goes in 4 times. What's the remainder over there? Well, 4 times 9 is 36. And 36 from 40 is 4. So it's 4/9. And this is in days. All right? You got that right over here. All right? So what does that mean? If A and B work together, it will take 4 and 4/9 days to complete the job. All right? Let's keep going. And these are, I'm going to say for some students are more difficult because when they're reading it, they're seeing it as being like a jumble of words without meaning. But what they claim over here, they say the second digit of a number exceeds the first by 2. All right? So I don't know what that really means, but they're talking about, the second digit of a number exceeds the first by 2. So they're clearly talking about a number that has 2 digits in this point. And then it goes on to say, if the number be divided by the sum of its digits, the quotient is 4 6/7. So what I'm going to do is I'll write that number down as a 2-digit number. I'll just put little lines over here. All right? And again, I'm not going to say it's the easiest thing to read, but I'm going to say, the first digit, this is the first digit. And that's a tens digit, by the way. I'm going to say I don't know what that number is, but it's an integer. And that integer over here, is going to be like 1, 2, 3, 4, 5, all the way up to 9. All right? Now, if it's a 2-digit number, I'm going to say x can't be 0. All right? Now, someone's going to say, I wonder what the second digit is. And again, this is the tens place. The tens place. I'm going to talk about this digit over here, and this is the ones place. Well, let's go back and read. It says the second digit of the number. Well, this is the second digit. The second digit of the number exceeds the first by 2. So this guy over here would be x plus 2. All right, that's what the digit is. Now, I'm starting to realize now, x has possibilities, and the possibilities, it couldn't be like, I guess 7 would be the largest one, right? Because 7 plus 2 is 9. But it couldn't be 8, because 8 plus 2 would give you a double-digit number, and I don't want that to happen. But let's not worry about that. What does it say? Let's read it. It says the second digit exceeds the first by 2. I got that pretty much written down. And it says if the number be divided, well, what's the number? The number is, I'll write this over here. The number is, what's it going to be? 10x. Again, that comes from here. Plus 1 times x plus 2. Let me just put that down for you. That's 10x plus x plus 2, which is 11x plus 2. All right? So let's read it again. It says, if the number, well, this is the number. If the number is divided by the sum of its digits, well, let's write this down. If the number is divided by the sum of the digits, well, I hope you realize the first digit's this, and the second digit's this. So what's the sum of the digits? That's not so bad. It's just 2x plus 2. Right, so they said, if the number is divided by the sum of the digits, the quotient would be 4 6/7. All right? Again, I want to remind you in algebra, we really don't like to use mixed numbers. So I need to clean this up a little bit. So I'm going to write it over here, 11x plus 2. I'm no longer thinking about the words in the problem. We'll get back to that later. And, I have to figure that out. It's, let's see, 28. 7 times 4 is 28. And again, what I'm talking about, this is a mixed number. It really means 4 and 6/7. I'm going to simplify that. So 28/7, which is 4, and 28 plus 6 is 34, right? What I'm going to do is multiply both sides by the LCD. And again, this is where some students might say, oh, I'm going to cross-multiply. That's just like multiplying by the LCD. But cross-multiplication, for some reason, is that we don't like to use that word anymore in algebra. I don't mind it, by the way, but let's use don't use that word. It's a terrible word. I don't find it a terrible word. But I'm going to multiply both sides by the LCD. The LCD is 2x plus 2 times 7. Let me put that down for you. 11x. I'm multiplying by that LCD. Whoops. Give me a second here. Times 7 equals 34 times 2x plus 2. Well, I guess I got to do that. That would be 77x plus 14. 34 times 2 is going to be 68x. 2 times 34 is 68. What I would do is I would take 68 from both sides. I'll put this over here. I would get 9x, and I would subtract 14 from both sides. And if you do that, what do you get? 54, right? Again, I want to go back, and if you don't remember what we've done, you can reread the problem. X is an integer number, and what do you get? You get 6. Now, someone says, I wonder what their question was. You go back and read it. And what's your question? Find the number. Well, what's the number? It's right over here. If x is 6, what would I get? Well, the number would be, let's write that down, 10 times 6, which is 60, and then x plus 2, which is 8. So what's the number going to be? 68. These are certainly written down for you. So it's not a bad question. But again, you might look at that saying it's very difficult. It's not. It's really going to be straightforward if you read it and understand. Could you be confused by what you read? Of course. What's the deal about this? We do put work down. We would like you to read that work and try to figure this thing out. All right? So here's the deal. We just did 2 questions. One was a work problem, and the other one was sort of like an integer relationship problem. Well, it's certainly a number. We had to figure that one out. And then what you got to do, oh, by the way, let me repeat it over here. My work is typed up for a reason. That's the way it should look. All right, my chicken scratch on the side is me just talking through that. So when you're doing it, yeah, there's going to be chicken scratch from you too on a piece of paper. Look at the key, all right? Now, if you're getting the right answers, you may not want to look at the work, but it can't hurt to read the work, all right? What I mean by that, read what I got typed up for you, all right? If you find any inconsistencies between my chicken scratch and the work, please bring it to my attention. Okay, so once you read the section of contents, do the examples, you really have to start thinking about doing the exercises, and that's really important. So someone's going to say, yeah, I need to do that. I'll get around to it. You got to get around to it like right away. You also may have to revisit what you've done just to review, and that happens particularly when you get to the level where you're getting exams. You got to go back and review because it's easy to forget stuff. It really is. So I'm going to say, what do I do in these problems over here? I read them, I do the work, and then I type it up. And that's what I did over here. So there is work over here for you to look at, but the bottom line, there is an answer. And I hope you can look at that and know what the answers are in the problem when you read that. Number 2, very similar to work problems. Number 3, this is like a digit problems with an integer has some numbers in it. Number 4, a fraction with fractions are a ratio of integers. With the bottom line, you try to understand what you've read and write down what you've read. Typically, always understanding that you're looking for something. So this one is another work problem. That may seem strange to you, but it's a tank that has 3 taps on it. All right. So taps could either remove water or they could add water to the tank. All right. Now, when I say water, it could be any liquid, but the tank does hold a liquid. All right. So next one is a train problem. And someone says, what's this all about? Well, it's still a work problem. And I want to point out what they mean. The work now is distance equals rate times time. It's still the same thing, uniform motion problem. All right. So next one, again, another digit relationship problem. And then, 9 is, another work problem. But someone says, I don't know what you mean by that. It's a distance equals rate times time problem. And again, these might be hard to do. All I'm saying is you do the problem, don't look at the answer key. Do the problem, then look at the answer key. You really need to come up with that. Now, someone says, why do you give me an answer key then? Well, to help you, right? It's like having a private tutor there at all times, showing you if you get stuck, you could look at someone's work though. All right? And again, there's a lot of problems over here. Do the problems though. The more problems you do, the better you get this. Some of the problems, I'll admit to you, are going to be difficult problems. There's no doubt about it. All right? They're going to be tough to read, tough to understand, tough to get through. Next up is this SAGE business over here. What's SAGE? SAGE is a computer algebra system. And a computer algebra system, often called just CAS. I'm recommending SAGE because it's free. What you can do is either download the application, if you have a computer that takes downloadable software, or use the interactive web-based application. which requires you have a browser that's compatible with Sage's website. Most browsers are, by the way. Yeah, type the code in. And what are you doing? You're looking at this code over here and trying to make sense out of it. And I really do mean that, trying to make sense out of it. Again, if you need to reach out to me, please do so, all right? And my email address, again, is banin. And again, if I get overwhelmed, I may not be able to respond, but I will try to respond, all right? Thanks for paying attention. I really do appreciate it. Thank you.